Hello students, hello everyone. Welcome to Senior College Mathematics. Topic of discussion is matrices and determinants. If you are in senior college, you are preparing for WAEC, for NECO, for GC, for NAPTEP, for JAMB, or any other external exams into high school all over the world, this topic, this lesson is for you. You are in the right place. Petakus Education Community. Lesson 9, Inverse of Matrix of Order 2. You know, order 2 matrices are 2 by 2 matrix with 2 rows and 2 columns. Before that, for updates, follow Petakus Educom via YouTube at Petakus Simplified Maths. To do that, subscribe to this channel, like this video, share this video to your friends, your colleagues, your classmates. You can also follow us via Facebook through fb.me/Petakus Educom, Instagram Petakus EC, Telegram t.me/Petakus Educom, WhatsApp through this mobile telephone number. In all of these platforms, you get updated from time to time about what is happening at Petakus Education Community, where you have access to quality, unlimited, and simplified mathematics teachings in series. Okay. Suppose A is a square matrix. Suppose A is a square matrix. What that means is that inverse is only defined for a square matrix or square matrices. The inverse of A, written as A to the power of -1. This power of -1 attached to any matrix defines its inverse. So A inverse exists if A times A inverse is equal to A inverse times A and is equal to I, where I is identity matrix. So if you find the product of a matrix and its inverse, if the result is identity matrix, it means the inverse exists. At the senior college level, the inverse of a matrix shall be restricted to matrix of order 2. That is, matrix with 2 rows and 2 columns. Square matrix order 2 precisely. Okay. Properties of inverse matrices. Property of inverse matrices or inverse of matrices. So if A and B are invertible, what that means is that if you can find the inverse of matrix A and C is a non-zero scalar, this is a constant, then the following properties are true. Number 1, if you find the inverse of a matrix, what you will have is the matrix itself. Then 2, if a matrix is raised to a power and you find its inverse is equal to the inverse of the matrix raised to the same power. You know, in lesson 6, we talk about powers of matrices. So this is related to it. Then number 3, if you multiply a matrix by a scalar and find the inverse, is the same thing as multiplying the inverse of the matrix by the reciprocal of the scalar. Reciprocal means 1 over the scalar C. Number 4, if you take the transpose of a matrix and find its inverse is the same as the inverse of the matrix, then you take the transpose. Number 5, if you take the inverse of the product of two matrices, it is the same as taking the inverse of the first matrix and the inverse of the second matrix, and you multiply both together. So these are the properties of inverse of a matrix. Okay, note the following. 1. Inverse of a matrix is defined for squared matrices, matrices with the same number of rows and columns. Note 2. If B is an inverse of A, then A is also an inverse of B. That is vice versa. 3. If A has an inverse, then A is said to be invertible. 4. Inverse of a matrix is unique. In other words, if you have two matrices A and B that are different, the inverse of A is different from inverse of B. That is the uniqueness we are talking about. Note 5. Every square matrix is not invertible. What does that mean? Remember, I told us that inverse is only possible if determinant of a matrix is not equal to 0. So a matrix that has determinant equal to 0 has no inverse. That is why every square matrix is not invertible. Hello? All right. Example 27. Show that B is an inverse of A if matrix A equal to this, matrix B equal to this. By definition, two matrices A and B are said to be inverse if AB equal to BA equal to I. That is identity matrix. Identity. So if AB, that is the product of A and B, is equal to the product of BA and is equal to identity matrix. What that means is that either AB is equal to identity matrix or BA equal to identity matrix. You don't look for AB and B at the same time. No, it's either you look for AB equal to I or BA equal to I. Okay, so let's take AB, that is matrix A times matrix B. You know, in lesson 4, 5, when we look at multiplication of matrices, we said to do that the number of columns in the first matrix must be equal to the number of rows in the second matrix before multiplication is possible. But you know, if you have two matrices of equal dimension, as we have A and B here, 2 by 2 matrices, it is obvious that the number of columns in matrix A is equal to number of rows in matrix B. So the product AB is defined as matrix C with this entry. So to get C11, that is first row, first column, you use the first row of matrix A to multiply the first column of matrix B, element by element. Remember, we're looking for the sum of product. So you multiply 2 by, that is 2 times 3 plus 1 times minus 5. That is, you take this 2 to multiply this 3, you add it to 1 multiplied by minus 5. You have 6 minus 5 equal to 0. To get 1, 2, C12, that is the same first row times second column of B. That is 2 times minus 1 plus 1 times 2. that is minus 2 plus 2 equal to 0. To get C21, that is second row, first column, you use the second row of matrix A to multiply the first column of matrix B. That is 5 times 3 plus 3 times minus 5. You have 15 minus 15 equal to 0. To get C22, C sub 22, that is C subscript 22, you use the same second row of matrix A to multiply the second column of matrix B. Element by element, you have 5 times minus 1 plus 3 times 2. That is minus 5 plus 6 equal to 1. So this is AB. So if you take AB, what is C11? That is 1. C12 is 0. C21 is 0. C22 is 1. So what you have now is identity matrix. Remember, in lesson 1, when we look at type of matrices, one of them is this matrix, and with identity matrix is a diagonal matrix. That means it is a square matrix, but the diagonal elements are unitary, equal to 1, while the one above and below are 0. Since the product of AB gives identity matrix, it means B is the inverse of matrix A. And if you look for BA and you have the same result, it therefore means that A is the inverse of B. So this is how we show that two matrices, they are inverse of one another. Hello. All right, let's continue. Example 28, but we look at the inverse of 2 by 2 matrices using system of linear equation. We use the first approach to find the inverse of 2 by 2 matrices. Okay? So find the inverse of this matrix. Like we said in lesson 1, every matrix has a name. This matrix in this example has no name, so you give it a name. And we have the choice of any letter of the alphabet. So we take A. So let A be equal to the matrices. Now I want to find the inverse of the matrix. The inverse denoted by A power minus 1 is not, and of course, you know, A inverse is another matrix that will be 2 by 2, since matrix A is 2 by 2. So let the inverse be A, B, C, D. These 2 by 2 matrix. From definition, inverse of a matrix exists if you multiply the inverse, if you multiply the matrix by its inverse, and the result is identity matrix. Now we know matrix A. We have assumed the inverse to be A, B, C, D. If you multiply A by its inverse, the result is I now. That is matrix A times matrix A inverse. So you write the corresponding 2 by 2 identity matrix 1, 0, 0, 1. So we are looking for this now. See that, looking for this. So I'm going to do that by system of linear equation. So let's multiply first the left hand side. Of course, the order is 2 by 2, so the conditions are satisfied. So you take the first row, 4 minus 3, to multiply AC. That is 4 times A plus minus 3 times C. That gives 4A minus 3C. The same first row times second column. You have 4 times B plus minus 3 times D. That is 4B minus 3D. Now you take the second row to multiply the first column. That is minus 1 times A plus 2 times C. You have minus A plus 2C. The same second row times second column. You have minus 1 times B plus 2 times D. That is minus B plus 2D equal to the right hand side. So by equality of matrices, it means that the entry in the first row 4a minus 3c is equal to the 1 here. But you know, we are using system of linear equation. So if you look at the 4 equations in the matrix now, the equations in the first column have the same variable a and c. So we have to pair the equations in the first column to the first column in the right hand side matrix. Then the equations in the second column, they have variable b and d in common. So you pair it with the second column of the matrix in the right hand side. That is b, that is 4a minus 3c equal to 1. Equation 1 minus a plus 2c now equal to 0 here. See that? That is equation 2. 4b minus 3d equal to 0. That is equation 3. Minus b plus 2d equal to 1. That is equation 4. So we solve equation 1 and 2. Then 3 and 4 simultaneously for AC, then BD. So let's go. Solve equation 1 and 2 simultaneously. So this is equation 1, equation 2. We want to use the method of elimination. In that method, you delete one variable and solve for the other. So I wish to eliminate variable A. To do that, variable A must have the same coefficient in both equations. In equation 1, the coefficient is 4, and equation 2, it is 1. You can say minus 1, okay? The LCM of 4 and 1 is 4. So you have to make the coefficient in both equations 4. To achieve that, multiply equation 1 by 1 for that 4 not to change. Then multiply equation 2 by 4. So that for us to have 4 attached to A in equation 2. If you multiply equation 1 by 1, it remains the same. It will not change. If you multiply through equation 2 by 4, you have minus 4a plus 8c plus 8c equal to 0. Okay? So we have to add. We are adding because the coefficients are both positive and negative. When the signs are different like this, you add. That is why here is addition. So 4a minus 4a, 0. You come here, minus 3c plus 8c, you have 5c. And 1 plus 0 is 1. So therefore, 5c is equal to 1. To get c, divide both sides by 5. And c is equal to 1 over 5. From this system, you also need a. To get a, substitute c value into equation 1 or 2. But I'm using equation 2. Equation 2, you have minus a plus 2c equal to 0. Minus a plus 2c equal to 0. And what is c? 1 over 5. It replaces c in this form. So let's come here first. If you open the bracket, you have minus a plus 2 times 1 over 5 is 2 over 5 equal to 0. Now to get a to be positive, you just transfer minus a to the right, it becomes positive, leaving 2 over 5 in the left. So therefore, a is equal to 2 over 5. So you know C and A. To solve for B and D, you take equation 3 and 4 simultaneously. So this is equation 3 and this is equation 4. Okay, so I wish to eliminate variable B first. To do that, B must have the same coefficient in both equations. Looking at B, the coefficients are 4 and 1. Their LCM is 4. That means you make going to be the same 4 and 4 in both equations. To achieve that, in equation 1, multiply it by 1 for the 4 to remain the same. Then equation 4, multiply it by 4. Equation 3, multiply it by 1. So if you multiply through equation 3 by 1, it remains the same. If you multiply equation 4 by 4 all through, you have minus 4b plus 8d equal to 4. So I'm going to add because the coefficients, they have opposite sign. So 4b minus 4b is 0. If you take 3 minus 3d plus 8d, you have 5d. 0 plus 4 is 4. So therefore 5d is equal to 4. Divide both sides by 5. D is equal to 4 over 5. In this system, you need B and D. Now that we know D, substitute D value into equation 4 to solve for B. So this is equation 4. And what is D? 4 over 5. If you open the bracket, you have minus B plus 8 over 5 equal to 1. That is 2 times 4 now is 8. Okay, so to get B, transfer minus B to the right, it becomes positive. You transfer 1 to the left, it becomes negative in this form. And you know you can write B all over 1. So the LCM of 5 and 1 is 5. That is what you have here. Divide 5 by 5. The first denominator you have 1. 1 times 8 is 8. Divide 5 by 1. Second denominator you have 5. 5 times this one is 5. So you have 8 minus 5 over 5 equal to B. So therefore B is 3 over 5. So we solve for A, B, C, D. So let's go back to the problem. Alright, this is the inverse now. So we solve for A, B, C, D. So you replace them with what they stand for. So let's go and do that. From the solution, A is 2 over 5. So you look at A here, 2 over 5. It replaces A. B is 3 over 5. Look at B, 3 over 5. It replaces B here. C is 1 over 5. You replace C, 1 over 5. And D is 4 over 5. All the entries half over 5. That means you can factor out 1 over 5. If you factor out 1 over 5, you are left with 2, 3, 1, 4 as the inverse of matrix A. Hello? Somebody shouted, voice of Petakus, this procedure is long, oh. Yes, but it is sweet. That is the system of linear equation. You want a shortcut, it's all right. So let's see the formula method that gives a shortcut for doing that. Okay, so formula method. If A is a 2 by 2 matrix given by A equal to A, B, C, D, then A is invertible if and only if AD minus BC is not equal to 0. Remember, this term here is determinant. Like I stated before, invert is possible if determinant is not equal to 0. equal to 0. Okay, so after doing that, so we have this as the inverse. So the inverse is 1 over determinant AD minus BC multiplied by, so in the inverse you interchange the position of AD to BD. See now, it has changed AD to BD. Then this diagonal, you negate it, meaning you multiply it by minus 1. So B times minus 1, you have minus B, and C times minus 1, you have minus C. Put this together, you have the inverse of 2 by 2 matrix. That is the formula approach to it. Okay? Okay, so let's see example. Example 29. Find the inverse of this matrix. By our notation, the first entry is A. So A is equal to 1, B is equal to minus 1, second entry, C is equal to 2, the third entry, D is equal to 3, the fourth entry. So this is the formula for the 2 by 2 matrix. So we have to check if AD minus BC is not equal to 0. That is the determinant before you proceed. Okay, so you have AD minus BC. A is 1. See that? From the notation now. What is D? D is 3. The determinant of 2 by 2 matrix is the difference of the product of the two diagonals. So this is the first diagonal. The difference now is minus. The second diagonal is minus 2 minus 1 times 2. So you have 3 minus times minus is plus. So 3 plus 2 is equal to 5. So you come, this is the inverse. So 1 over AD minus BC, that is 5, 1 over 5. So you come here and see that. So where's your D now? D is 3. And what is B? B is minus 1. If you put minus 1 this place, you have minus minus 1. That is 1. What is C? C is 2. If you put 2 here, you have minus 2. See that now? And A is 1. That is the inverse of 2 by 2 matrix. So I'm going to verify that one we solve with system of linear equation and be sure if we have the same results. All right. So verification of example 28 using the formula method. So this is the matrix. You find the inverse of this matrix. Okay. So we give it a name, matrix A equal to this. So by definition, the first entry is monitor A now. Second entry is B equal to minus 3. C is minus 1 and D is 2. So this is definition of the matrix as we have stated earlier. So let's look for AD minus BC. That is 4 times 2 minus 3 minus 1. So 4 times 2 is 8. You have minus 3 times minus 1 is plus 3 now. So you have 8 minus 3 equal to 5. So this is the inverse now. A inverse is equal to 1 over AD minus B, 1 over 5 now. So let's come here. So what is D now? D is 2. 2 is there. What is B? B is minus 3. If you put minus 3 here, it becomes minus 3. That is plus 3. What is C? C is 1. If you put minus 1 here, you have minus 1. That is plus 1. And A is 4. So that is the inverse. So let's check it with that solution. So you see that now? You see that the inverse is the same as the one we have using formula approach. Okay? Alright, the inverse is the same. End of lesson 9. Thanks for watching and learning with Petakus education community. Don't forget, watch out for more from the voice of Petakus. For inquiry and questions, use the comment section and we attend to them. For the complete package of this topic, lesson 1 to 11, for offline usage, contact the voice of Petakus via this WhatsApp number or through the email address. Lastly, if you are not safe, your life will be in crisis. To avoid that, you give your life to the one that can save you, and that is the Lord Jesus Christ. If you are saved already, I tell you, big congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take care of yourself, stay out of trouble, study your books, do the needful at all times, flee every appearance of evil, don't defraud others to make money, use your hands and your brain to work genuinely, and the Lord will bless you. Voice of Petakus say thank you and goodbye for now.